Well, remember these dimensions because we'll use it in modeling this out. So our column is CGHSS. We don't need the height of the column. This is just a section design for a connection. So we don't need the height. You can play around with this. The model type. The model type is as in accordance with your support. What was the assumption in your support? Do you assume this to be fixed? If you assumed it to be fixed, then you definitely have moments introduced to your foundation or to your nodes. If you could consider just the wires, sometimes this we use based on what are your critical forces. Right, taking account that this is a vertical member, so your shear force in the z direction, your movement in the y direction should be taken account for. If this or this, and this, if you assumed it should be pinned or hinged, as the case may be. So you can use this for the let's start on this. We don't go too far. You just assumption. These are determined by your design assumptions, your analysis, and your end forces which you've gotten. Then head over to the connection. Using this, you could change this. Go over here to change this. Click on the plus sign to change your design parameters. S35, S275. You can use this. Thickness of your plate system as determined by our forces in our Tekla structure or dimensions in our Tekla structures. So part 16, anchored 575. Check our previous tutorial on how to model this. You greatly understand where you're coming from. So head over to this. This will be 500. Is there you want circular or rectangular? So these are the options only provided for by their statica. So it's best you watch it from the top. Z houses. If we remember, the top houses is aligned, so there is no offset. Right side has an offset of 25. So here, let's see top. So this should be the top. Yes. Like this should be 25. Yes. The layers should be minus 45 by minus 25. So minus 75 by minus 100. then this the left layer should be, let's say, 50. Okay, so put -75. Okay, this is just this is more trial and error. But as you get used to the software, then you know how this applies. But the best way to is to get over to the dictor. It's a 2D 1 3 1 2 3 4 5 6 1 2 3 4 5 6. Choose this, gives you the dimensions: 100 100 100 100 75 75 150. And this, so explode it. This is 75. So this, you don't have any issues with this. The problem is with this. So this is, we change it. This is at the centroid or at the center. So moving 100 100. So we need 75. So 100 minus 70. If you take out 75 from 100, that will give you 25. So when we say 1 2 5, should get 75. 1 2 5, that should get to 75. Then we'll head over here. Distance from this board to this is 125, which is here. So the issue will come down to this 5 and 6. I will do minus 125 minus 125. So we've successfully molded this as it was in our Tekla structures. Take it from this. Could have imported it, but it's best I show you how to do this manually. Sometimes doing it manually is better than importing it. So okay, let's see some clashes. We'll check when we run the dimensions, when we run the calculations, I mean, when we run the calculations, to check if you have to reduce this. This is why section checks are very important in designs. We'll head over. Try and reduce this, is way too big. Way too big concrete block. Concrete is 65, 300, 600, etc. This is 200 by 300. This is 600, 300. Okay, this is 600, and this is 300, 300. Offset away from. We'll still go with this. Let's say 500. Let's say 250. No, 200. Let's say this 200 by 400. We'll try that. phone is way too small. That's okay. We'll try it out. Frictions or shear loss are by anchors. Shear force transfer should be by friction. Your waist and your material. The flanges, this was a 2. So let's say 5. Or 6 to 4. So I say below or within the limit specified. And the next thing is to your loads. We don't remember we can't select moments anymore because in the model type we chose just our normal forces and our shear forces. So we went over to the loads. 300 kilonewton. Do you have any shear force? We'll just assume this. We're using pure assumption with no specified load, so we can calculate this. Calculate. So our calculation is complete. As our analysis is 100% place, and no shear forces in the body, no forces in the plate, ankles, waist. You can say the shear you have 0 without any shear forces assumed. So let's say we assumed 100. Let's calculate. As expected, when we specify a shear force, you can see so probably the shear, so we won't bother us, but all these are just assumptions. So we don't have a real shear. 100 kilonewton shear force is actually high, not very high, but it's high. So we can use 35 or 34 on the calculation again. As I once said, these forces are assumed. You have to carry out your analysis to determine the forces. So I'm doing this just for you to see how to activate the shear calculation. So let's do the 3D. You can see the ankles forces are. So to this, in this calculations, so this is practically don't have not being used. These ankle forces are the ones carrying the brunt or the load. So we head over to our check. No buckling analysis calculated. So you can see this, you can go through all this. You can see our plate. To check your plate, go down what else it is. Concrete check. So our concrete check. Concrete block is 15.6%, so it's still within the limit. The equivalent stresses Let's see, here are our stresses. So the mesh should be here so that you see it properly. Look how much stresses. Our stresses are way low. Our deform structure. And deformation shows you so many things. So is the structure behaving as it's meant to behave? So let's check. Okay. Can create a scale. Let's say there's not much deformation here. So bring it down 10. Can we go to stresses and contact? Of our both forces. Of last strain. Equivalent stress. For the both forces. We don't have much stresses, so our stresses are very low. So this is just to show you this is what you do. This is not, I'm not calculating or doing any design here. I'm just showing you. You can see our plate forces. No much stress on these members. They're so minimal. To the ankles, can enlarge this. The rest are my order. So that concludes the tutorial for this simple base plate. In the next video, we'll handle this connection. This with stiffening ribs. Thank you. Please don't forget to subscribe.